Hello. In this section, I will apply and demonstrate the mean value theorem. So we're going to do the mean value theorem. So what is the mean value theorem? So I'm going to just read it out and then I will explain. So if f is continuous on the closed interval from bracket a to b and differentiable on the interval parentheses a comma b or open interval a to b, such that f prime equals to f of b minus f of a is all over b minus a. Note, continuous means no breaks or holes. Something that is differentiable means there's no cups, no sharp turns, no breakpoint, and no vertical tangent at a point. So here are examples that are not differentiable or continuous. So this one has a cusp. This one has it's open circle and a dark circle. It's discontinuous, and this one has a vertical tangent. Okay, so let's kind of briefly explain what that means, what the mean value theorem is. So maybe this graph could help. So let's say we had 2 points. We'll call this point here, I'll call this A, and then I'll call this point B, right? So if you connect, so we have this graph and we'll call this A and B. Now, if you make a dashed line from points A to B, that gives you a slope. So that's also called the rate of change, right? Now, if you pick 2 points on this graph, for example, this point right here, I'll call this C, and then I'll call this other point right here C2. And if you make a dashed line on that slope, if you find the slope of that point, this is called the average rate of change. So the average rate of change and the instantaneous rate of change will be the same. And then there's a point. So you have like a C1 and a C2. So yeah, so you have a graph, you have 2 points, A and B. There is a point between A and B that is such that at that point, C1 has the same slope. C1 and C2 has the same slope of the instantaneous rate of change. Okay. Yeah, so slope of average rate of change is the same as the slope of instantaneous rate of change. Okay, so I think we need to do an example to explain. So for example, 1 and 2, determine whether the mean value theorem can be applied to f on the closed interval bracket a to b. If the mean value theorem can be applied, find all values c. So we got to find these 2 points or 1 point in the open interval of a to b, such that f prime of c equals to fb, f of b minus f of a all over b minus a. Okay, so let's apply the mean value theorem for this one. So this -2 and 1 is like our a value. So let's kind of like draw it. First, let's find what the y value when the x value is -2 and what's the y value when the x value is 1. So let's do that. So let's do f of -2. So that would be -2 square, which is 4. So that point right there is going to be at -2, 4. And then let's do f of 1. So this is 1 square, which is 1. So that point right there would be 1, 1. Okay, so it's good to graph it just to see if it's actually if it applies the first part, it continuous on the interval and then differentiable on that point. Okay. Let's do a little graph. Okay, so here's -2, 4. And then 1, Oops, there's 1, 1. So this is a prop, so it would look something like, so it's a parabola, so I know it goes to the point 0, 0. So it would look something like this. So let's apply, let's see if it actually applies the first two steps. So is it continuous on the closed interval from A to B? Yes. So if you look at from -2 to 1, there's no open circles, there's no you're not lifting up your pencil, so it is continuous. And then is it also differentiable from A to B? So if you look at our graph, there is no cusp, there's no sharp turns, there is no tangent at vertical line, right? So it doesn't look anything like these three examples. No cusp, no discontinuous, and there's no vertical tangent. So this means that we can actually apply the mean value theorem. So what that means is if you make a dashed line between A and B, so that's from this point from here, there's going to be a point, right here. There's going to be a point here that will have the same slope as the instantaneous rate. So this is the instantaneous rate. This is the instantaneous rate of change. And we're going to find this point that will have the same slope as the instantaneous rate. Okay, that's all. That is pretty much what mean value theorem is. So let's find that point. So what we're going to do is so we found the 2 points. Now let's okay, so we have 2 points, 2 points. So let's find the slope. We have the 2 points, -2, 4, and then 1, 1. So this is x1, y1, x2, y2. So let's find the slope. So the slope is going to be 1 minus 4 over x2 is 1 minus a minus 2. So 1 minus 4 is -3. 2 negatives becomes a positive, so that's 3. So that's -1. So our slope is going to be -1. So the slope, what they mean is this slope right here is -1. Okay, now what we're going to do is we're going to do f prime of x. So we're going to take the derivative of f of x. So the derivative of f of x, well, what's the derivative of x squared? It's just 2x, right? Then we're going to replace f prime of x with the rate of change, which is -1, or the instantaneous rate of change. And then, so this is going to be -1 equals to 2x. And then divide this by 2. So you get an x value of -1/2. Okay. Now, how do we got to find the y value because this is a point. So to find the y value, you're going to do you're going to do f prime of the x value, which is -1/2. So you're going to put -1/2 into this function. So that would be 2 times -1/2, which is going to be -1. So we have a point at -1/2, comma -1. So what does that point mean? So that point would be about here because this is the only one. So if you see this is tangent, right? And if you make a slope or a slope or tangent, it's going to give you so if you make the same slope as this of this point, this is the point. Okay, so that was that one. Let's do one more example. So example 2, f of x equals x cubed from the intervals 0 to 1. So first we got to make sure it's the first two steps, we got to make sure it's continuous and differentiable. So this is your A and your B. So let's find f of 0. So the f of 0 is going to be at 0 cubed, which is 0. So that point there is going to be 0, 0. And then the other one is f of 1, which is 1 cubed, which is 1. So that point would be at 1, 1. Okay. So maybe it would help if we kind of drew the image to see if it is continuous and differentiable. So this is an XQ. So if you XQ, well, what is an XQ graph? It kind of looks like, it looks like that, right? So this part right here is going to be, it's going to have a little curve, just like this part. Okay, so is it continuous from A to B? Yes, it is continuous, right? Is it differentiable? Yes, there's no sharp terms, no cuffs, no vertical and tangent lines, so it is differentiable. So we can apply the mean value theorem. So we have 2 points, 0, 0, and 1, 1. Let's find the slope, x1, y1, x2, y2. So my slope is going to be 1 minus 0 over 1 minus 0, which is 1. And then let's find f prime of x. So if our graph was x cubed, f prime of x would be 3x squared. And then what are we going to do next? We are going to we're going to replace m with f prime of x because that is our tangent. 1 equals 3x squared. Then we're going to try to solve for x. So I'm going to divide this by 3, divide this by 3. So I get 1/3 equals to x squared. Take the square root. So this is going to be plus or minus, well, square root of 1 is 1 over radical 3. And then if you rationalize the denominator, so you get an x value of plus or minus radical 3 over 3. Okay. Then let's find the 2 points. So the 2 points is going to be, so if we do f prime of radical, did I make a mistake? Yeah, this is right. So this would be 1 radical 3. Yes, this is 1. Yes. Okay. So it would be first. Let's try the positive one. So radical 3 over 3 equals to 3 radical 3 over 3 square. So that's 3, and then radical 3 square is 3, and then 3 square is 9. So 3 times 3 is 9 over 9, which is 1. Okay, so your first point would be at radical 3 over 3 comma 1. Let's find our other point, f prime of negative radical 3 over 3. So that's 3 radical 3 over 3 square, 3, 3, 9. Whoops, minus. So this is negative 1. So your other point would be at negative. Wait, no, I'm right. It was positive because negative radical 3 is positive. Good. So this is positive. So then another point would be at negative radical 3 over 3, comma 1. Okay, so those are your 2 points. Okay, so that pretty much wraps it up for mean value theorem. Thank you. Bye-bye.